All right. So this is still chapter 7 on chemical bonds. This is 7.2 about ionic bonds. Okay. And again, I encourage you to start off looking at those lesson objectives. Describe how ionic bonds form. Use properties of ionic compound or list properties of ionic compound. The lesson vocabulary is ionic bond and ionic compound. Right, so those are the things we should be expecting to learn from this lesson. All right off the bat, it tells us that in some other compounds called ionic compounds, atoms transfer electrons. Okay, so there are two types of bonds. Let's say chemical bonds. All right, one type is the ionic bond, which is what this chapter is about, or this lesson. The other kind is covalent. What that paragraph just told us is that in ionic bonds, we transfer electrons. And it also told us that in a covalent bond, we share electrons. Now, which electrons do we share? The valence electrons. In chemical bonds, the valence electrons are involved. In an ionic chemical bond, the valence electrons are transferred. In a covalent chemical bond, the valence electrons are shared. Okay? Now, right now we're going to focus on ionic bonds that transfer electrons. An example is our old friend sodium and chlorine. Now, sodium is a metal. So I'm going to digress a minute here. Go to a new page. All right. I'll make a very rough drawing of the periodic table. All right. Everything in group 1 has one valence electron. Everything in group 2 has two valence electrons. Now, groups 3 through 12, we don't really talk about in physical science. They're the transition metals, and they do some weird things with their valence electrons. Everything in group 13 has 3 valence. Everything in group 14 has 4 valence. Right? Everything in group 15 has 5 valence. Everything in group 16 has 6 valence. Everything in group 17 has 7 valence. Okay? Now group 18 is a little special. Okay? Everything down here in group 18 has 8 valence electrons. This is helium. It only has 2 valence. But as we discussed before, group 18 is the noble gases. Okay? And they're called the noble gases because they have a full outer shell. They don't want to bond with anybody. So helium, even though it only has 2 valence electrons, is stable. It does not react with anything because it has a full outer shell. The other elements in group 18 may or may not have a full outer shell, but they have 8 valence electrons. So every noble gas has an octet. It follows the octet rule. It either has a full shell or it has 8 valence electrons. Okay? Now, so what we're talking about here, everything in group 1, 1 valence. Group 2, 2 valence. Group 3, 3 valence, so forth and so on. Okay? Everything in group 18 has 8 valence except for helium, it has 2. And we're not talking about the transition metals in groups 3 through 12. All right, so let's go back. Now, sodium is in group 1. And since it's in group 1, How many valence electrons does it have? Correct. It has one valence electron. Okay. So by putting that dot there, I have now created an electron dot diagram for sodium. That's all there is to it. The symbol and dots for the valence electron. Now, sodium has 11 electrons. If we drew the Bohr model, okay, you would have 2 electrons in the first shell. You would have 8, 1, 2, 3, 4, 5, 6, 7, 8 in the second shell, and 1 in the third shell. Okay, but that's a lot to draw, and I'm lazy. Okay, so we're going to not do that. All right. What we are going to do is this dot diagram that shows me exactly how many valence electrons sodium has. Chlorine is in group 17. Okay, so think back, how many valence electrons should it have? Pause if you need to. All right, so chlorine in group 17 has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Now, the thing is, metals tend, so this was group, got ahead of myself, this is group 17. This has 1 valence electron. This has 7 valence electrons. We know that because it's in group 17. Okay. Sodium is a metal. Right? Chlorine is a nonmetal. Right? And metals tend to lose electrons. They lose those valence electrons. Right? And nonmetals tend to gain electrons. That's a G. Right? Now, when electrons are negative, so when you lose an electron, you're losing a negative. So when metals lose electrons, they become positive ions. So they become positive ion. That's a plus sign, positive. Okay? Nonmetals gain electrons. That means they gain negatives. And if you gain negatives, you become negative. So nonmetals become a negative ion. Okay? Another name for a positive ion is a cation. C-A-T-I-O-N. Another name for a negative ion, okay, is an anion. A-N-I, oops, one button. Oops, no, let's do that. A-N-I-O-N, okay? So cation is a positive ion. Anion is a negative ion. And the way I remember that is that cation has a plus sign in the middle of the word. Okay, so cation is a positive. An anion, an means not. So that's a negative term. So anion means negative. Right? So positive ion, negative ion. All right. Well, Mr. Frollo, we're supposed to be learning about bonding. Well, we're getting there, I promise you. All right, so metals want to lose their electrons. So this sodium is going to lose an electron. Chlorine is a nonmetal. They want to gain electrons. Okay, they want to gain electrons. All right, so they're going to gain that electron. So now what has happened is sodium now it's dropped down to where it had those 8 electrons. So now it has an octet. It is happy. As long as it's like that, it's happy. Chlorine now has an octet. It has 8 valence electrons. So as long as sodium and chlorine are together, they have an octet and they're happy. So sodium has become a positive ion because it lost an electron. Chlorine has become a negative ion because it gained an electron. Gaining electrons makes you negative. Losing electrons makes you positive. All right. So what's happening here, and I'm going to go to another page in order to go over this one more time and a little clearer. So the sodium atom, this is a sodium atom, lost an electron and became a sodium ion. It's an ion because it has a positive charge. The chlorine atom became a chlorine ion. Again, it's an ion because it has a charge. Any atom with a charge is an ion. So sodium becomes a positive ion, chlorine becomes a negative ion. Because they're opposite charges. Remember, opposites attract, likes, repel. Okay, so these are opposite charges. So the sodium is attracted to the chlorine. The chlorine is attracted to sodium. Now we had a word for an attraction between atoms. What was that word? Yeah, sodium and chlorine form a chemical bond because they're ions, they're oppositely charged ions. And so we write that as NaCl. That is the formula for table salt. Okay, sodium chloride. And because this is a ion and this is an ion, this is called an ionic bond. Okay, it means having to do with. So this literally means having to do with ions. So this is an ionic bond between ions. Right? Now, if we go back to the periodic table, everything, let's see here. Over here, there's that stair-step line. And you may remember that the stair-step line are metalloids. Right? And then everything pretty much over here, except for hydrogen, thing over here are the metals. And then everything over here, including hydrogen over here, are the nonmetals. Right? Now, the reason I point this out is we said that metals lose electrons and become positive ions. Okay? And nonmetals gain electrons and become a negative ion. Okay? So that means an ionic bond is always between a metal and a nonmetal. So that's a takeaway. Okay? Ionic bonds are always between a metal, which are on the left of the periodic table, and a nonmetal, which is on the right. Right? So an ionic bond forms between ions. Those ions are always a metal and a nonmetal. All right. 7.2. Why ionic bonds form? We've already talked about this. It's because you have a positive ion and a negative ion. They attract each other. Remember that positive is always going to be a metal, and the negative is always going to be a nonmetal. Okay. All right, so let's look down here. Okay. It takes energy to remove electrons from an atom. The force of attraction between the negative electrons and positive nucleus must be overcome. So you can't just take an electron away from an atom. It's attracted to the nucleus because the electron is negative, right? So here's the nucleus. It's got those positive protons and the neutral neutrons, and then the electrons are negative. So there's an attraction between the nucleus and the electrons. In order to remove an electron, you have to overcome that attraction. Okay? Less energy is needed to remove just one or a few electrons than many. This explains why sodium and other alkali metals form positive ions so easily. They only have one electron to lose, so it doesn't take much energy. Okay. In bigger atoms, valence electrons are farther from the nucleus. As a result, the force of attraction between the electrons and nucleus is weaker. Okay. All right. Ionic compounds. This was one of our objectives, as you may recall. Ionic compounds contain ions of metals and nonmetals held together by an ionic bond. Right? So that's important right there. Ionic compounds do not form molecules. Instead, many positive and negative ions bond together to form a structure called a crystal. Okay? So ionic bonds form crystals. That's why salt is a crystal. You can see an example in figure 7.5, shows the ionic compound sodium chloride, which is salt. Okay? So that's one of those properties of ionic compounds. They form crystals. Okay? Whoops. All right, properties of ionic compounds. The crystal structure of an ionic compound is strong and rigid. That makes them, well, it kind of makes them brittle. When you hit them with a hammer, they're going to break. They're not going to bend like a metal. They're going to break. It takes a lot of energy to break all those strong ionic bonds, right? So if you wanted to melt, say, salt, table salt, you would have to heat it up a lot because it takes a lot of energy to break the attraction between those ions. Okay. As a result, ionic compounds are solids with high melting points and boiling points. Okay, so you have to heat them up way high to melt them, and you have to heat them up even more to boil them. Okay, the rigid crystals are brittle and more likely to break. Okay, ionic crystals tend to shatter. Okay, so those are all properties of ionic compounds. Right? Here's some melting and boiling points. So in order to get sodium chloride to melt, you have to heat it to 801 degrees Celsius. And if you want that liquid to boil, you have to heat it to 1,413 degrees Celsius. Okay? For a frame of reference, if you want to boil water to make your macaroni and cheese, water boils at 100 degrees Celsius. Okay? So the boiling point of sodium chloride, table salt, is 8 times higher than the, I'm sorry, I'll take that back. So this is the boiling point of water, right? H2O boiling point. The H2O melting point is 0 degrees Celsius. Okay, so the sodium chloride melting point is 800 times higher than the melting point of H2O. The boiling point is 14 times higher than the boiling point of water. So they're both way up there. Okay, so the takeaway, okay, is ionic compounds are brittle. They have high melting and what that was, and boiling points. Okay, and then uses of ionic compounds. Many ionic compounds are used in industry. The human body also needs several ions for good health. You ever hear someone talk about electrolytes? Like Gatorade has electrolytes to, help you when you're exhausted from exercise. Those electrolytes are actually ions. That's what they are. Okay. Having low levels of the ions can endanger important functions such as heartbeat. Solutions of ionic compounds can be used to restore the ions. All right, so lesson summary. An ionic bond is the force of attraction that holds together oppositely charged ions. So an ionic bond is a force of attraction between oppositely charged ions. It forms when atoms of a metal transfer electrons to atoms of nonmetals. So it forms when atoms of a metal transfer to atoms of a nonmetal. When this happens, the atoms become oppositely charged ions. Ionic crystals form crystals instead of molecules. Ionic bonds are strong and the crystals are rigid. As a result, ionic compounds are brittle solids with high melting points and boiling points. In the liquid state or dissolved in water, ionic compounds are good conductors of electricity. Right? So ionic compounds form crystals. They are strong and the crystals are rigid. Ionic compounds are brittle solids with high melting and boiling points. In the liquid state or when they are dissolved in water, they conduct electricity. They do not conduct electricity as a solid. Right? So that is the end of 7.2. Right? I hope to see you in 7.3.